Hi everyone, Mr. Eric Kua here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Okay guys, let's go through this question from Hua Chong from their paper 3. Okay, so we know this question is about phosphorus, blah, blah, blah. Okay, so the first compound that comes up, C18H29SO3Na, the MR of 348. Okay, they can react with calcium in hot water to give a precipitate. Okay, so they give you this KSP equation. Okay, then they say a particular brand of detergent contains 17.4% by mass of this salt. In hot water, 1 gram should be used with 1 dm cube of water. Typical hot water contains 2.5 times 10 to the power minus 4 mole per dm cube of calcium. Okay, so they give you the calcium concentration in hot water. You may assume that volume of 1 gram of detergent is negligible compared to 1 dm cube of hot water. Alright, so that's the question. Part 1, explain why is it not necessary to include the concentration of this salt solid in the KSP expression. Most of you will know the answer because pure water and pure solid, their concentration is constant. Okay, so this is a pretty standard tutorial question. Part 2, explain why a precipitate will form when 1 gram is added to 1 dm cube of hot water. Okay, so first we need to calculate the concentration of the anion from 1 gram. Okay, we know that it's 17.4% by mass. Alright, so we just need to calculate the mass that is made out of this salt and then divide by the MR, which is given as 348. Get the number of moles and then sub into the KSP or IP expression. Okay, so this early part is to get the mass of salt. Once you got the mass, you divide by MR. Okay, you get the number of moles in 1 gram. Okay, so this is the number of moles of the salt in 1 gram. We know the concentration of calcium in hot water that's given by the question at the start here. So we already have the anion and the cation. We just need to substitute these two values into the expression. Okay, so this is our ionic product as calculated. So we compare that to the KSP that's given, which is 1.2 times 10 to the power minus 17. So since your ionic product is greater than your KSP, a precipitate will be formed. Okay, so that's for part 2. Part 3, calculate the maximum concentration of calcium 2+ in hot water for the detergent to be effective. Okay, so we want it to be effective, so we'll just let the IP equals to KSP. Or IP smaller than KSP, smaller or equal. Okay, then no precipitate will be formed. Okay, so we sub in the value for the KSP, and then we sub in the value for the salt. Okay, so we find that the maximum amount of calcium, right, that can be present where the IP is equal or smaller than this value is 4.8 times 10 to the power 11. Any value of calcium greater than this, you will get a precipitate. Okay, so this is the maximum amount. Okay, second part of the question, they say that sodium tripolyphosphate is added as a softening agent So it can complex with calcium to prevent formation of the precipitate. As shown by this equation, they have given us the Kc value. Write down the expression. I think this is fairly straightforward. Put down the expression. Product over reactants. A. Part 5, some of this sodium tripolyphosphate was added to hot water containing the detergent. After forming, it decreased to 1/10 its original value at equilibrium. Using the Kc value, calculate concentration of calcium 2 plus. Okay, so basically we got to understand, right? This being the Kc expression, what do they mean when they say decrease to 1/10? Remember that for this equilibrium, right? The amount of the complex is 0 at the start. Alright, so after you add in this sodium polyphosphate, this anion decreased to 1/10 of its original value, which means that 90% of it converted to calcium complex. So 9/10 of it converted to the complex. Okay, so that's why we put this ratio here. It is actually 0.9x, 0.1x, but the x will cancel out because we do not know what's the original value, right? But since it cancels out, we can simply use the ratio, plug in the KSP value here on the left, and then we just solve for the new concentration of calcium after you've added in this sodium tripolyphosphate. Okay, so hence, if we look at this answer, right, and then we reference A part 3, A part 5, is this amount sufficient to make the detergent effective? Okay, so you look at A part 3, this is the maximum calcium that can be allowed before a precipitate forms. So is our amount here lesser than 4.8 times 10 to the power minus 11? Looks like it's not. So since it is still more than it, we will still get a precipitate and the detergent is still ineffective.